As a critical component in new energy research and development, the assembly quality of coin cells directly influences the accurate evaluation of material performance. Manual coin cell assembly often faces dual challenges of low efficiency and inconsistent quality, becoming a long-standing bottleneck in the advancement of material R&D. Single-sided coated electrodes are especially prone to curling, resulting in high rates of misalignment and poor assembly consistency. Furthermore, variations in material diameter make manual placement difficult to quantify and control, leading to cumulative errors. To address these challenges, IEST has developed the Coin Cell Automatic Assembly System (CAAS), which redefines industry standards through advanced automation technologies, greatly enhancing both R&D efficiency and data reliability. Key features and advantages: high throughput, precision robotics, electrode handling, accurate positioning, custom fixtures, automated sealing, intelligent monitoring, inline voltage testing, user-friendly operation, industrial-grade consistency, inline voltage testing. Integrated voltage testing modules provide online performance validation of each assembled cell. User-friendly operation. The system significantly lowers the skill threshold for operators, allowing staff to master coin cell assembly without intensive training. Industrial-grade consistency. Assembled coin cells meet the consistency standards required by leading lithium battery manufacturers. Performance metrics: NCM and LFP cathode electrodes, charge and discharge specific capacity less than 1.5 mAh per gram. Graphite anode electrodes, charge capacity less than 1.5 mAh per gram, and discharge capacity less than 2.0 mAh per gram. Silicon-based anode electrodes, charge and discharge specific capacity less than 20 mAh per gram. The successful development of CAAS signifies the advent of a standardization era for coin cell assembly. Looking ahead, the deeper integration of AI and IoT technologies will pave the way for full-chain automation, from material handling and assembly to final performance testing, transforming the future of battery R&D.